Okay, good morning class. So today we're going to learn about chapter 9.4, relationship between types of surface of object and heat absorption and emission. Okay, let's talk about absorption and radiation of heat first. Have you ever wondered why fuel tanks, like the one that you see on the road, are painted in bright colors such as white or silver? Okay, in Malaysia, maybe we'll see yellow, which is Shell, and also light green for Petronas, right? This is because bright colors do not absorb a lot of heat. Therefore, evaporation of the fuel is reduced. And also because this thing is fuel, right? Fuel is inside here, and what happens if we get fuel too hot? There is a risk of it burning. Okay, so the ability of an object to absorb or radiate heat depends on the type and color of its surface. So right now you have to understand that the color, okay, or type of the surface is very important in determining whether it absorb or emit more or less heat. Okay, so let's have a look. If we conduct this experiment, which aims to see how a dark object absorbs and radiates heat better than white object. Alright, so if we take this setup over here, right, we have basically two cans inside two cans placed next to a source of heat. Alright, and one is milk can painted in white and another one is painted in black. So what do you think? Which one will get hotter? From what we talked about previously, right up here, in theory, technically, after leaving this on for, let's say for example, 5 minutes, this one will increase in temperature. The other one will also increase in temperature, but not as much. Alright? So we can say that, let's say for example, the initial temperature is 25. So which one will get hotter? Eventually, you'll notice that J, for example, the one with white, would get maybe 32 degrees Celsius, and then the black one maybe 40 degrees Celsius. Right? So we can actually say that the dark object will absorb more heat, and hence it will become hotter. Alright? Now let's talk about radiating heat. So we do the opposite situation, where instead of heating up the object, we let it cool down. So when we talk about heat radiator, we're actually talking about releasing heat energy, right? In simple terms, cooling down. So according to our theory, the black object over here will cool down faster. Alright? So black or dark object cools down faster, whereas white and shinier objects will cool down a lot slower. So how can we actually see this in real life? Let's say if you have, like, for example, plates in your house made of, for example, ceramic. If you have a white one and a black one, try put it under the sun for maybe 5 minutes, and then you'll see which plate will get hotter. Now we can actually visualize this using technology. This is a FLIR camera system where it detects infrared light, and it will actually see basically heat vision for your surroundings. So have a look at this. This car over here is obviously the white one, and this car over here is the black one. So you can see that the bright spots over here, let's say here, okay, for this camera, the brighter the color means, the brighter the color in this screen, okay, not to be confused with the material, means hotter, okay? So as you can see, the hood of this car over here and over here, which is here and here, you can see that over here is actually hotter on the thermal camera, where here is cooler. Another way you can actually see how it goes is if you put a bunch of crayons from dark to bright in the sun, and then, for example, this case, they were left for about 4 hours, and what they found out was the black one basically melted, whereas the white one is still intact. Alright? So, as a summary, you see dark and dull objects, they are good heat absorbers, whereas white and shiny objects are poor heat absorbers. Okay, when an object absorbs heat, the temperature increases. That's why it gets hotter. And when it radiates heat, it will get cooler. Okay, so when an object absorbs heat, it will increase in its temperatures increase. However, when an object radiates heat, its temperature decrease. Dark and dull surfaces are better heat absorbers and radiators compared to white and shiny surface. So the big question is why? Alright, to explain why, we actually have to look at your Form 1 syllabus, where, remember, you learned this last year, where you have white light going through a prism and you get a bunch of colors. So this phenomena, you have to understand that white light, okay, can be split into all the colors, or in other words, all these different colors will combine to form white light. And then now, why are green objects green? Obviously, because they absorb all the different color light except for green. And why are yellow objects yellow? Because they absorb all the colors that do not make yellow, and they add, for example, green, yellow, and red. A few of those colors will combine to make yellow, right? Now, what does this have to do with why do dark objects absorb more heat? Okay, for white objects, look at this. For white or bright objects, a lot of this light are not absorbed. They are basically just reflected away. White objects appear white in white light because the white objects reflect all colors in white light. Alright? However, for dark objects, such as black, they appear black because it absorbs all the light. So, all of these light rays, wavelengths of light, are absorbed, whereas the one over here is reflected. Right? And now you have to understand that all of this light, we also have it as light energy. Okay? So all this light energy will be converted into heat energy. Okay? So the more light you absorb, for example, in a dark object, the more the more light energy you absorb, the more of that energy will be converted into heat energy. Whereas if you have a situation where it's white or bright, a lot of the light energy is actually reflected, so it's not actually absorbed by the white object. Hence, the temperature does not increase as much. Okay? Now, that's for heat absorbers. What about radiators? We talked a little bit about radiators, and it's actually quite hard to find information of why dark objects radiate heat that much. But for a very good summary for your level is a good absorber is a good emitter. Okay? Emitter or good is a good absorber is a good emitter, or a good absorber is good at radiating heat. Okay. Alright, if you actually want to go into detail, we will actually have to talk about Kirchhoff's law of thermal radiation, which is actually very too high for your level. I mean, look at this formula. Would you be able to understand it right now? But the long summary, I mean the short summary of all of this thing is basically, at any given wavelength, a body absorbs and emits radiation with the same efficiency. Hence, if good absorber will basically be good emitter, and also if you have a bad absorber, you will also get a bad emitter of heat. Okay, so this is a very short lesson on 9.3, relationship between types of surface of the object and heat absorption and emission. Right? Thank you.